Now, if you see any typical failure of the fracture surface, it is a crankshaft where you have a hole. It comes out to be as a stress concentration razor, where the maximum local stress will be more, and crack will be initiating from there. It will propagate in the flat mode, and after a certain point, you will due to overload, static load, it will failure. So this is the typical characteristic of fatigue, and this is showing the type of thing you will have a crack initiation. I mean, it's possible by seeing the fracture surface where the crack initiation started, and by seeing the smoothness of the surface, and during the cyclic, it will leave telltale sign of striation or beachmark. So during accident, they do investigate the striation that will each cycle, even if it whether it's 1 megapascal, 10 megapascal, 100 megapascal, it will leave a telltale sign of striation. Only it's question of whether you will able to see it or not. That's a different issue. You have to use different aids, but naked eye you cannot see. Naked eye only it will show the flat, and the matting will be both opposite to each other. So this is different type of failure fracture surface. The left hand side is mostly ductile, and your right side is brittle. There's nothing much in the fatigue crack. So I hope you are know the difference between what is the brittle fracture and ductile fracture, and the middle one is in between. So if you see the fracture surface characteristic in general, so generally we'll have a ductile failure, looks like cup and cone. Then if it's a brittle, there are two types of mode. One is called intergranular, where crack failure may occurs along the boundary of the grain, or it can be transgranular, that is across the grain. But when it comes to fatigue, you will have beachmark, that's a striation, which is visible or observable using scanning electron microscope. You can identify initiation site, you can identify propagation sites, and also final fracture surface. This is what can be seen there. And there are different categories of fatigue. What we have been talking only aircraft or something, but usually requirement is to validate, to ensure that structure is can withstand the fatigue at a different category. So one is mechanical fatigue that may occur due to the stress strain. Then thermal fatigue, if there is a variation in temperature, it will induce the thermal stresses. And of course, acoustic and sonic fatigue, that occurs due to the jet engines. So you know the engine will be mounted in the pylon, and whenever exhaust gas jets out, it will go as a cone, and the gas will have from DC value to up to megahertz frequency. And the chances that the gas may hit your rear fuselage or may the tail plane, and each structure has got a natural frequency. If some of them matches with the gas thing, then only some resonance will take place. But though it is far away, the fact that it's not lead to the catastrophic failure, but it does required for analyzing the sonic fatigue as one of the FR requirement. And even your satellites thing, they do acoustic chamber tests. NL, they have acoustic chamber. So basically during launching, it creates a lot of noise, so that your inside equipment thing has to withstand. So that's what has to be studied. Then corrosion of fatigue, of course, is the presence of mechanical loading as well as environmental, like offshore structures, ships, aircraft in Navy. Then you have a fatigue petting that occurs due to the relative displacement of two parts. Like the lap joint, you have a cyclic loading. If there is a clearance between two rivets, that will rise to your fretting. People who are in engine, the blade is been fixed to the disc in a certain way, right? That is the main thing, is that corrugated, that's called we-fill thing, right? That's right. What is it called? We-fill locking system, right? It will have like this serrated one with the triangular thing, V notch. That other one will be opposite, so they will be tight fixed. So that is basically required to prevent any fatigue. Because
Dovetail joints, right, sir?
Pardon me?
Dovetail joints at the fixing.
Yeah, correct. That you have seen the shape, right? It's a corrugated one. It
Correct.
tightly
Yes,
fitted that. So that is basically because it undergoes high centrifugal force. Every time you do one cycle starting running and down, So to prevent relative displacement, that's why they put that. That's also
Okay.
matter. Obviously, vibration fatigue that comes due to the compression pumps and all. That has to be done. But we will be discussing more about the mechanical fatigue.